Hello, and welcome to the session on nth term of a quadratic sequence. What are we going to learn in this lesson? First, we'll try and understand what are quadratic sequences and what are the characteristics of such sequences. We'll then go on to find out, given a rule, how do we go on to find out the terms of a quadratic sequence? And finally, we'll understand, given different terms of a quadratic sequence, how do we derive the rule for the sequence? Let's begin then. What is a quadratic sequence? Well, a quadratic sequence has the highest power of n in its nth term as 2, which means we should always have a n squared as the highest power of n when we derive the rule for the nth term. A simple example for quadratic sequence is nth term given by n squared. For example, if I want to find the first term, all I need to do is find 1 squared, which is 1. The second term would be 2 squared, which is 4. Third term is 3 squared, 9. Fourth term is 4 squared, 16. And fifth term is 5 squared, 25. Well, that's how we derive the terms of a sequence whose nth term is given. The rule is given as n squared, right? Now, one of the characteristics of a quadratic sequence is that the second difference between the consecutive terms is always constant. Now, what do we understand by the second difference? It's basically difference of difference. Didn't understand? So let's first find the first difference between the consecutive terms of this sequence. So 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7, and 25 minus 16 is 9. So this is the first difference between the consecutive terms of the sequence. The second difference would be the difference of these differences. For example, 5 take away 3 is 2, 7 take away 5 is 2, 9 take away 7 is 2. So as you can see, the second difference, which is the difference of the differences, in a quadratic sequence will always be constant. As you can see, it's always 2 in this particular case. It can be any other value, but it's always constant, right? Now, how do we derive the rule for the nth term of a quadratic sequence? Let's start with simple sequences whose nth term are given by rules as simple as an squared, okay, something times n squared. But before we understand how to derive the rule, let's first understand, given the rule, how do we arrive at the terms of a quadratic sequence? So let's take two such sequences, one following rule, which is 2n squared. The nth term is given by 2n squared. And the second one with nth term given by 5n squared. So let's first derive the terms, the first 5 terms of each of these sequences. In the first case, the first term will be 2 times 1 squared, which is 2. Second term will be 2 times 2 squared, which is 8. The third term will be 2 times 3 squared, which is 18. The fourth term will be 2 times 4 squared, which is 32. And the fifth term will be 2 times 5 squared, which is 50. Remember, for each term, all I need to do is replace n with that term number. For third term, n is 3, fifth term, n is 5. Right, so these are the first 5 terms of the sequence given by 2n squared. Let's find the difference of the consecutive terms of this sequence. 8 minus 2 is 6, 18 minus 8 is 10, 32 minus 18 is 14, 50 minus 32 is 18. What's the second difference then? 10 minus 6 is 4, 14 minus 10 is 4, 18 minus 14 is 4. As expected, the difference is constant, which is 4. Let's now look at the second sequence. Its n term is given by the rule 5n squared. Let's derive the first 5 terms of that sequence. First term would be 5 times 1 squared, which is 5. Second term would be 5 times 2 squared, which is 20. Third term would be 5 times 3 squared, which is 45. Fourth term, 5 times 4 squared, which is 80. And fifth term will be 5 times 5 squared, which is 125. Let's find the difference of the consecutive terms. 20 minus 5, 15. 45 minus 20, 25. 80 minus 45 is 35. And 125 minus 80 is 45. What's the second difference now? Well, 25 minus 15 is 10. 35 minus 25 is 10. 45 minus 35 is 10. Once again, as expected, that second difference is constant. Now, here's the interesting thing. I want you to look at the second differences in each of the sequences and figure out how are they linked to the number which is getting multiplied to n squared. For example, in the first case, how is 4, which is the constant second difference, linked to 2, right? 2n squared, 2 getting multiplied to n squared. Likewise, okay, look at the second sequence now. The second difference is 10. How do you think is that linked to 5? Now, in each case, you will realize that the constant second difference is being divided by 2 to arrive at the number which gets multiplied to n squared, which means if the sequence has a rule a n squared, then a is found by dividing the second difference by 2. The second difference in a quadratic sequence is constant, so that constant value needs to be halved, divided by 2, to arrive at the value of a, which is the coefficient of n squared in the rule. Remember that, right? And now that we understood this, we can always go the reverse way, which means if I'm given the terms of a sequence, we can always find the nth term, the rule for the nth term, right? For example, 3, 12, 27, 48, 75. These are the terms in the sequence, right? What are the differences? As you can see, the differences are 9, 15, 21, and 27. That's the first difference. And the second difference, as you can see, is 6 in each case. What that means is to arrive at A, all I need to do is divide 6 by 2, which is 3. So the rule for this particular sequence is un, which is the nth term, is given by 3n squared. Look, it was easy, right? All I need to do is divide the second difference, which is constant value, by 2 to arrive at A. Well, let's now make things a little difficult. Let's look at sequences which are of the form un equals to an squared plus c, which means we have a n squared term plus the constant term. Okay. Now, once again, before we understand how do we derive the rule for such sequences, let us first go the reverse. We'll look at such sequences and then link it to the rule. Let's look at a simple sequence which follows the rule un equals to 2n squared. Okay, and the term is given by 2n squared. So we have seen that particular sequence a little while early, right? A little while back. 2, 8, 18, 32, 50, 72. Okay, each of them is twice the square of the corresponding term, right? 1 squared, double that, it's 2. 2 squared is 4, double that, it's 8. 3 squared is 9, double that, it's 18, and so on. Now, if I add 1 to each term of this sequence, what should we get? Well, we should get a new sequence, which is 3, 9, 19, 33, 51, 73, right? Likewise, if I were to subtract, because we have arrived at this sequence by adding 1 to each term of the original sequence, the rule for that sequence should be 2n squared plus 1, right? Because the original sequence was 2n squared. And because we added 1 to each term, the sequence would now have a rule which is 2n squared plus 1. Likewise, okay, if I were to subtract 2 from each term of the original sequence, what is the sequence that we'll end up getting? We'll get 0, 6, 16, 30, 48, and 70, right? And what do you think will be the rule for this new sequence? Well, because we subtracted 2 from every term of the original sequence, this one will have a rule 2n squared minus 2. It's as simple as that. Correct? Now, the big question is, how do we arrive at that extra constant which is getting added, like a plus 1 in the first case and minus 2 in the second case? Now, listen to this very carefully. For that, all we need to do is, to the original sequence, which is in the middle, you add the previous term to the first term, which means first term was 2. We just add the previous term, which is 0. Because if there was a 0th term, it would follow the rule 2 times 0 squared, right? How much is 0 squared? 0. 2 times that is 0. So the previous term would obviously be 0. Correct? And now if I were to add 1, what will the previous term to the sequence on top? It will be 1. And if I subtract 2, what will be the 0th term of the sequence at the bottom? It will be minus 2. And these are your constants. Remember, plus 1 goes in as plus 1 and minus 2 goes in as minus 2. Right? Interesting, right? So just to sum up, all we need to do is find the difference between the consecutive terms of the sequence, which in the above sequence it is 6, 10, 14, 18, 22, and so on. Because I can see that it's going up in fours, the difference between 3 and the previous term would be 2, right? Because the constant difference between the differences is 4. 6 to 10 is 4, 10 to 14 is 4, and so on. So the previous difference should be 2. So 3 minus 2 is 1. So all I need to do is, you need to somehow find the term which is previous to the first term of the sequence, and that goes in as your constant in the rule. Let's try with that with the second sequence, which is at the bottom. The difference between the consecutive terms, as you can see, is 6, 10, 14, 18, 22. Once again, the difference is going up in fours, as you can see, 6 to 10, 4, 10 to 14, 4, and so on. So the difference which is previous to 6 would be 2. Correct? Because it is going up in fours, so we subtract 4 from 6 to get 2. And 0 minus 2 is minus 2. So the previous term to the original sequence in this case will be minus 2. And that's your constant value, which is getting added, as minus 2 is the constant which is getting added. Right? Now with this background, let's try and work out the rule for such sequence now. Okay. So let's say I have given the 5 terms of a particular sequence. How do we derive the rule for such sequence? So first step, we write the sequence terms, which is 5, 14, 29, 50, 77. Find the difference of the consecutive terms, which in this case are 9, 15, 21, and 25. Find the difference of differences, the second difference that is, which is a constant value of 6 in this case. That gives you the value of a, right? And an squared. Remember the coefficient of n squared. So you divide by 2, the constant difference, divide by 2, which is 3. So your sequence starts with 3n squared. That's sorted. That was your original thing. Now, how do we get that constant? For that, we need to take a step behind, right? So if the difference was 6, okay, the second difference is 6. The difference previous to 9 should have been 3, right? Because if you look at the differences, the first differences is going up in sixes. 9 plus 6, 15, plus 6, 21, plus, right? Which means if I were to go 6 behind 9, I will end up at 3. And 5 minus 3 is 2. So the term which is previous to the first term of that sequence is 2 plus 2. And hence, the rule for the sequence will be 3n squared plus 2. So all I need to do is to find the constant value. You need to just go to the step which is previous to the first term. Right. And finally, let's get to the most complicated quadratic sequences, which is of the form un equals to an squared plus bn plus c. It has all the 3 terms, okay, n squared, n, and the constant. So if you're given such a sequence, your first step should always be to find A. The second step should be to find the constant value, which is C. This can be done using the two methods that we learned earlier. And finally, we should find B, which is in step 3. We'll learn how to do that. Let's look at a sequence: 7, 12, 19, 28, 39, 52. Now, how do we go about finding the rule for this sequence? Let's go to step number 1. For that, we need to find the difference between the consecutive terms. In this case, it is 5, 7, 9, 11, 13. Find the difference of each of these differences, which is 2. Divide this constant difference by 2 to arrive at the value of A, which is 1. So I'll replace A by 1 in the original rule. Correct? Now, second step is to find C. How do we find C? All we need to do is find the term which is previous to 7. For that, we need to track the difference behind, right? So if the difference is 2, then the difference previous to that should have been 3. And hence the term previous to 7 should have been 4, right? So I'll replace C with 4, right? So we have got A, we have got C. Now all I need to do is find B. Now how do we find B? For that, I pick up any one term of the sequence. Okay, for sake of simplicity, we just pick the first term, which is 7. That's U1. So if I were to replace n by 1 in my original rule, I should end up getting 7, okay, as the final answer, because that's your first term. So let's do that. So because A was 1, it will be 1 times 1 squared. Why 1 squared? Because it's the first term. Plus B times 1, because B is the unknown, right? And n is 1. So B times 1 plus the constant 4 should be equal to 7, right? And if I solve this equation, you'll get B as 2. You replace B by 2, and that's how you derive the rule for the quadratic sequence. It's n squared plus 2n plus 4. So remember, the first step was to find A. The second step was to find C. They are the easiest of both steps. And the third step is to find B, wherein you pick any one term of the sequence, okay, replace n with the term number, and then find B. Let's do one more example just to understand it better. Here is the sequence: 3, 11, 25, 45, 71, 103. Let's go step by step. Step number 1, to find A, you find the first difference, which is 8, 14, 20, 26, 32. Then you find the second difference, which are 6, 6, 6, and 6. So A would be 6 divided by 2, which is 3, right? So I'll replace A by 3. Second step, let's find C. For that, I need to find the term which is prior to 3 in my original sequence. For that, I need to track the differences behind. So 8 minus 6 is 2, and 3 minus 2 is 1, which means C will be equal to 1. So we have tracked A and C. All I need to do is now find B. For that, I pick any one term of the sequence, and always remember, the first term will be the smallest, and hence that's the simplest to find. So for first term, I'll replace n equals to 1 in the original equation, original rule. So we have 3 times 1 squared plus B times 1 plus 1. And what's the first term equal to? The first term is equal to 3. So I'll equate it to 3. All I need to do is now solve the equation for B. In this case, B is minus 1. So I'll replace B with minus 1. And there you get your rule for this particular sequence. Un given by 3n squared minus n plus 1. Right? Now this looks like a little complicated stuff, but if you can go through the video, pause it and take notes, I think you will understand it better. So this is this was the session on finding the nth term of a quadratic sequence. I hope you understood this concepts taught in this lesson, three things we learned. Okay, one is what is a quadratic sequence and what are the characteristics of quadratic sequences. Second, we understood if I'm given a rule for a quadratic sequence, how do we come up with the different terms of that sequence? And finally, given the terms of a sequence, how do we derive the rules of a quadratic sequence? Starting with the simple sequences of an squared to the complicated sequences of the form an squared plus bn plus c. We saw everything. Thanks a lot.